All right, welcome finally to the last section of Chapter 1. This is Section 1.7. This was a long ride, but I believe you learned a lot of good stuff, especially stuff that'll help you with AP Calc. Section 1.7 is called Inverse Relations and Functions. The essential question is, what is an inverse? What do they look like? And how do I find one? Okay, so that talks a lot of stuff. So we're going to take this step by step, make sure we get this, and it's not too hard. It should be pretty easy for you. All right, so what we're going to learn, how to use the horizontal line test. We've already talked about the vertical line test to determine inverse functions, and we're going to find inverse functions algebraically and graphically. All right. So what is an inverse relation? So basically this is saying, what is an inverse? All right. An inverse relation exists if and only if one relation contains b comma a whenever the other relation contains a comma b. Okay, that won't make any sense until we actually look at what that means. Okay, so let's say I have one function, and if I plug in 2, I get 3. If I plug in 4, I get 6. If I plug in 5, I get 8. All right. Then the inverse, so here's the function. Okay, I don't know what function it is, but let's say that function gives you these points. And then let's say this is the inverse. Okay, what inverses do is they flip-flop x and y. So BA turns into AB. So instead of 2, 3, we're going to do 3, 2. Instead of 4, 6, we're going to do 6, 4. Instead of 5, 8, we're going to do 8, 5. So what inverses and functions are is they take their x, y, all of their points are flip-flopped. Okay? And if you can prove that one function and its inverse have flip-flop points, then you know it is then they're inverses of each other. Okay? Inverse just kind of means the opposite or reverse. All right. Inverses are always reflections over the line y equals x. So you can graph inverses as well. Okay, so here is a function, all right, y equals x squared. Here is its inverse. Okay, y equals plus or minus root x. Now, I'm not worried about being able to find this yet. I'm just telling you that x squared and plus or minus square root of x are inverses. And this definition says they are always reflections over the line y equals x. So if I draw that in, y equals x is one of our parent functions. It's this diagonal line through the origin. You can see that this parabola here, right here, okay, so that part of the line reflects to here. And then this part of the parabola reflects to here. Okay, so you can see that that parabola is reflected. Therefore, they are inverses of each other if they are a reflection over that line. All right. Last thing we need to talk about before we look at some examples is if the inverse relation of a function f is also a function. So if the function and its inverse are also functions, then it is called an inverse function. And we use this right here, this notation. This means inverse function. Okay, so let's look and see. All right, so let's look at the one we just did. All right, let's see. Let me make a line here. All right, I'm going to change it to red really quick. All right, so does our original function, this parabola here, pass the vertical line test? So this parabola. Yes, it does. Okay, so f of x does. Now let's look at our inverse. Does this sideways parabola pass the vertical line test? No. How do I know? Because it touches right here. Oops, I need to change my color. So this graph touches right here and right here at the same time. So this one does not have an inverse function. All right, it has an inverse, but not an inverse function. All right, so let's look at this first one or the second one. So this top line passes the vertical line test. It never touches more than once. Does the bottom line do the same thing? Yes. So if it does, all right. So let's see here. So this first line is our function. The second line would be called our inverse function because they're both functions. All right. So does it pass the vertical line test on both of them? Yes. All right. Not all functions have inverse functions. They must pass what we call the horizontal line test. All right, so let me draw an example of a graph. All right, so let's see here. Let me do this. Let me go down a little lower. All right, so here is an example. Okay, this looks like an x cubed graph. Now, the question is, does it pass the horizontal line test? All right, so I need another line here. I'm going to make this line a different color so you can see it better. All right, so we have this line now. Vertical test shows if something's a function. Horizontal line test tells you if a function has an inverse function. So does this graph, this green line, ever touch this red line more than once? Okay, no. It passes the horizontal line test. So this one will have, okay, an inverse function. All right, now let me show you an example of one that will not. All right, so let me go here. Let me draw an absolute value graph. Absolute value graphs are V's. All right, now, does a V pass the vertical line or the horizontal line test? If you can see right here, this graph is going to cross this red horizontal line twice. So this will not have a function, inverse function. All right, does it pass the horizontal line test? All right, so let's do an example. It says graph each of the following functions on the graphic calculator, which I've done for you, and apply the horizontal line test. Determine whether its inverse function exists. So we're going to do the same thing. So here's 4 over x. Does this graph ever touch this vertical line in more than one spot? I don't think it does. Okay, so will it have a function? Yes, it will. So this one would be, yes, it does. Yes, it has an inverse function. Okay, what about the second one? We just did this one. Okay, this is a absolute value. This one touches more than once. So the answer to the question is no, F inverse. So no inverse function. All right? All right, moving along. Now we have to be able to find inverse functions. If a function passes the horizontal line test, then it is said to be one-to-one. That means that no x values match to more than one y value and no y values match to more than one x value. We don't need to really worry about this too much, right? Basically, if it's one-to-one, okay, if it's one-to-one, it has an inverse. All right, now we need to find steps of finding inverses. Okay, step 1, check to see if the function has an inverse. Does it pass the horizontal line test? Okay. Step 2, we're going to switch x and y. Step 3, we're going to solve for new y. All right, so let's look at these. All right, so we're going to look at these examples. Determine whether the function has an inverse. If it does, find it. All right, so here's our first equation. Y equals square root of x minus 4. All right, so I've typed that into my calculator. Square root of x minus 4. Let's graph it. Does it pass the horizontal line test? So if I drag a horizontal line here, okay, will it cross more than once? You can see no, that it won't. So it passes the horizontal line test. So this one's going to have a function. All right, step 2. So this equation is really y equals square root of x minus 4. Step 2 is to switch x and y. Literally, just take your x and your y and switch them. So x equals square root of y minus 4. All right. Step 3 is to solve for y. Solve for y. And I'm getting these steps from right down on the last slide. So we're going to solve for y. So how do I get rid of this square root to get rid of out of my problem? I'm going to square. To get rid of a square root, we square it. That means I'm going to square the left side as well. So the power of 2 and the square root go away. I'm left with y minus 4 is equal to x squared. And then last but not least, I need to get y by itself, so I'm going to add 4. So the 4's go away. I'm left with y equals x squared plus 4. Okay, and there's my inverse. So if you were to graph this on your calculator, you would see that it would be reflected over the line y equals x. So let's do that really quick. So x squared plus 4 graph. Okay, now this one looks a little different. Okay, I don't know if I can draw on here. I can't. But really, this parabola has a bottom to it. I didn't do the bottom part, so let me do the bottom part. So I did the positive square root. I also need to do the negative square root. So negative square root of x minus 4. And then that should give us the bottom half. So there it is. It is a reflection over that diagonal line that goes through. Okay, so there it is. All right, let's do the second one now. The second one's a little bit harder. Okay, I'm going to tell you that it has a function, it has an inverse. So let's switch x and y. So x equals y minus 1 over y plus 2. All right, this one is quite a bit harder, so let's do the steps here. So I need to get rid of this division by y plus 2. So I'm going to multiply both sides by y plus 2. Okay, y plus 2 over y plus 2 go away. I'm left with y minus 1 equals x. So now I need to distribute here. X times y is xy. x times 2 is 2x. All right. Now, I need the y's on one side and the x's on the other. Okay, so I'm going to subtract 2x to the other side. And that will give me xy equals y minus 1 minus 2x. And then how do I get this y on the other side? So I'm going to subtract y. So xy minus y is equal to negative 1 minus 2x. All right, so this one is pretty difficult. All right, let's wait for that bell. So I need to get this y by itself, so I'm going to factor it out. I'm going to factor a y out. So when I remove a y from xy, I have x left over. And when I take this y out, I have minus 1 left over. Okay, equals negative 1 minus 2x. So now I have y times x minus 1. To get rid of times, I divide by x minus 1. Divide by x minus 1. Right, so x minus 1 over x minus 1 go away. I'm left with y equals negative 1 minus 2x all over x minus 1. And there is my inverse. Okay, that's pretty tough. Hopefully that'll make sense. If you need to pause and go back and redo, please do. All right. Last but not least, composition of inverses. Two functions are inverses if and only if you take their compositions and it's equal to x, and you take the composition of the other, so this one is f of g of x and this one's g of f of x. So if you take the compositions and their answer is equal to x both ways, you know they are inverses. All right, so let's do an example. It says show that the following two functions are inverses of each other using compositions. So we are going to do f of g of x, and we're going to hope that it's equal to x. All right, so what does that mean? That means I'm going to take my g function and I'm going to put it inside of f. All right, so I'm going to take my g and I'm going to put it inside of f everywhere I see an x. All right, so I have 6 over x. Well, my new x is 6 over x plus 4, and then I have a minus 4 left over. All right, so let's see what this is equal to. Let's simplify. So 6 over 6 plus x. What's positive 4 minus 4? Those cancel. So I'm left with 6 over x. Okay? When you divide by a fraction, that means you need to multiply by the reciprocal. So 6 times x over 6. 6's cancel. I'm left with x. So we just showed that f of g of x is equal to x. What I want you to do is I want you to do the opposite. I want you to plug f into g and prove that it is equal to x. Okay, we'll do this in class at the end or at the beginning so we can all make sure that we're on the same page. That's it. That's chapter 1. We are finally officially done. I will see you tomorrow.